prove geometrically Sn equals Tn minus 1 plus Tn for n greater than or equal to 2. Sn here represents a square number, and the subscript n represents the position, so it's the nth square number. And we talk about the t before triangular number. So Tn minus 1 is n minus 1th triangular number, and Tn will be the nth triangular number. So we try to prove the nth square number equals the sum of these two triangular numbers. So in this video, because we're going to talk about the proof, the geometric proof. So in the homework, there will be two proofs. One is geometric proof, the other is algebra proof. In the other video, we're going to talk about how to prove this algebraically. So geometrically, that means you have to use geometry, the shape, the dots, to prove them. And but algebraically, you don't use the dots. You will just use algebra, the expressions. So let's see how we're gonna do that. First, let's take a look at the square number. So by the definition, by the name, we know that square number, for example, we're gonna start with S2. S1 will just be one dot, one row and one column. So only one dot. If we have two, S2 means two rows and two dots, two columns, two rows, two columns. And we can count how many here. That's exactly 4 dots, and you can draw them, and that would be a square. And S3 would be 3 rows and 3 dots, 3 columns, and that's a square also. And S4 we will have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And so the question would be, how do we draw Sn? Similar to drawing Tn and Tn minus 1, we're going to use, so I'm going to first draw maybe the first 4 dots, and draw the last dot. For the dots between them, I'm going to draw some little dots to represent the ones I didn't draw. Again, if n is 10, I'm missing these 3 dots will represent the missing 5 dots. If n is 100, these 3 little dots will represent the 95 dots I didn't draw. So that's why I use a different color, or you can make them smaller. Okay, so if you want to omit something, and especially if you if you have lots of like 100 numbers or 100 dots, you don't want to draw all of them. So you would just draw first few and the last few, or just last one, and maybe we can draw last 2, and to represent the beginning and the end, and the middle ones can be omitted by using 3 little dots. Okay, so we can continue to do this, and we draw the second row, the first 4 and the last 2, and the third row, and fourth row. And how many rows do we have to draw? It really, it's up to you. And then we have to use dots, because let me draw the last 2 rows, and I'm going to use black color to represent the dots I omitted. So we have a few dots omitted here, a few dots omitted here, a few dots omitted here, and a few dots omitted here, here, and here, here, here. 1, 2, 3, 2, 3. Okay, so this shape represents Sn. If we look at the first row, although we only draw 6 big dots plus 3 little dots, but you need to remember they don't really represent 9 dots. This represent n dots. We have n dots in the first row, and similarly we have n dots in the second row. So when you look at each side, it's always n dots. The reason we have to use little dots because we don't know what n is. Okay, let's try to divide the shape. So this is SN, the geometric shape, and I'm going to show that this shape, this square, can be divided into 2 triangular numbers. And how do we divide them? If you have trouble looking at this directly, we can start with the first few square numbers, so we have a better understanding of the problem, and maybe we can find the answer for the general case. And general case is the one we want to prove for any n. So this n right here represents n is arbitrary, so you cannot just prove for n equal to 2 or n equals 3. You have to prove for the general case. Okay, but we can get a pattern from the general special cases. So for example, S2, we want to show S2 equals, if n equals 2, then n minus 1 is 1. So pretty much we need to show S2 equals T1 plus T2. And T1 we know has 3 dots, and T2 has T1 has 1 dot, and the T2 has 3 dots. So we want to show 4 dots can be divided into 1 dot and 3 dots. So how do we divide the dots? And so the easiest way would be just put a line right here. How do you draw the line? You can just draw a slant line, or if you want, you can. The other way to do is you can draw something like this maybe. So I'm going to use the other way. So because I want to show it's a triangular number. Okay, so you can see the square can be divided into 2 triangles, and the top, that's a triangle, and the bottom has 3 dots, that's also a triangle. So you can see 4 dots, S2, can be the graph, the square can be divided into 2 triangles. One has 1 dot, the other has 3 dots. And S3, we need to show if n equals 3, T2 plus T3. And a T2, we know that's 3 dots, and T3 6 dots. So we need to show 9 dots can be divided into 3 dots plus 6 dots. And so 3 dots, T2 means 2 row, 2 dots in the first row and 1 dot in the second row. So that gives us an idea. Probably we can do something like that. So we cut right above the third row, right behind the second row, or above the third row, and also the third column in the so draw a line. And so the top, you can see there are exactly 3 dots, and the bottom we have exactly, if I just draw them together, that's exactly 6 dots, because we have first row 1 dot, second row 2 dots, and the third row 3 dots. So 1 dot on the first row, 2 dots on the second row, and 3 dots on the third row. So again, we proved that the third triangular square number can be written as the second triangular number plus the third triangular with the geometric shape. Okay, so we kind of, after looking at the first 2 cases, we kind of figure out the pattern. The pattern is, if you want to divide it into 2 triangular numbers, you will start from you draw a line right above the last row and right before the last column, and so you can divide the square into 2 parts, and the top part is going to be this is going to be our T3. If you look at the shape, 3 rows, 3 dots on the top, second row 2 dots and the bottom 1 dot. So that's exactly a triangular shape, triangular number. And if you look at the bottom, that is top 1 dot, top row 1 dot, second row 2 dots, third row 3 dots, and then 4 dots. So that's exactly T4. So we got the idea from the special case. For the general case, we can do the same thing. Right above the nth row and nth column right here, we can draw a line. I'm going to use a different color to do that, to separate, since we already have black dots in the graph. Okay. All right, so we divide the square into 2 parts. The top, we can verify the top shape is going to be exactly n-1 triangular number, and the bottom shape is going to be exactly our nth triangular number. So let's take a look. The top row, how many dots? Because we cut right before the last dot, and we know the top row has each row has n dots. So and we take 1 away. We saved this one for the other triangle, the bottom triangle. So the top row should have exactly n-1 dots. So from here, 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 remember the dots omitted here, plus the last one here. So we have n-1 dots. And the second row, n-2 dots and n-3 dots. And when you go all the way down, you got exactly 1 dot. So that's exactly n-1th triangular number. Because we have the bottom row, we have n-1 dots, and top row has 1. And in an increasing order, the number of dots are put in an increasing order from 1 to n-1. And look at the bottom triangle, it's kind of the same way. The top has 1 dot, second row 2 dots, third row 3 dots, and when you go all the way down, you got the bottom row did not miss any dots on the bottom. So we have exactly n dots. So top row 1 dot, 2 dots, all the way when you go to n dots, and you know that's T-n-1. Well, you can count how many rows you have, because from here 1 row to second row, third row, fourth row, and so on, you go to the very bottom, nth row. But for the top triangle, we have 1 row, 2 rows, 3 rows, and because we did not include this very last dot right here, and so we are only going to have n-1 rows. So that's our n-1 triangular number, and the bottom triangle is nth triangular number. So now we use the shape. So when you do the homework, this is the shape we need. You can draw the first few to help you to get the pattern, but the last shape is what we need. So we need to show this, that a square shape, dots, can be divided into 2 triangular shaped dots.